Colombian floriculture is highly relevant thanks to the fact that Colombia, as a country of very particular climatic conditions, not only for the development of flowers, but in general for the development of many agricultural products. And that is why Colombia, being so mega-diverse in crops, is called to be not only a great producer of flowers but also a great producer of food that is exported to the world. The conditions in Colombia, unlike other countries, happen because Colombia is located in the tropics, and in this area of the tropics we have conditions of light, radiation and some very particular conditions that allow the flowers to fulfill their cycles of development and of growth, with the best of the potential of its variety. The varieties have a development potential that is expressed very well for the conditions of Colombia. Thanks to these climatic conditions, Colombia ranks as the second largest producer and exporter of cut flowers in the world. This allows reaching more than 100 countries with all these requirements, and something very important that Colombia has, is the ability to offer varieties and species. Colombia, in these particular climatic conditions of our country, allow the power to have many species in many conditions that adapt very well, not only to the climatic conditions of our country but also to the market conditions and to those demands that are imposed on the countries to those we export. My name is Lincoln Salgar. I am the technical director of the Don Eusebio Agro-Industrial Farm, where we are now located. This farm is located in Hato Grande in the Sabana de Bogotá. The production process of the carnation begins with the planting of the sowings, which is in accordance with the needs of the market and that of our clients. And with that planting of the sowings, we proceed to the eradication of the old beds, the beds that they have already completed their cycle. And when planting the new ones that come for the production cycle, the planting work is carried out in a medium. A suitable medium or substrate that we call it, which consists of a mixture of burned husk, raw husk and reused substrate. This planting is raised from the ground. The main reason is to favor non-contamination by Fusarium oxysporum, which is the disease that most devastates carnation cultivation. The Colombian Floriculture Innovation Center works on many lines of research and innovation, but particularly the new trends in integrated management, in addition to market demands, require us to be increasingly solid in some of these lines, particularly what has to be do with genetic improvement, biological control, space-time analysis and monitoring of pests and diseases, and everything that has to do with data capture and understanding of these data within a system and an environment that allows us to be more competitive and add value through innovation. The principle of biological control, not only in floriculture but in general, in systems, agro-industrial and agricultural, corresponds to being able to use living organisms, to control living organisms that are considered pests, In that sense, insects for example such as trips or organisms such as mites that affect floriculture, are controlled with other organisms such as the mites themselves. Then we have two scenarios, some mites that are predators that we could call mites good and other mites that are definitely considered pests. Being able to release these beneficial organisms would reduce the populations of thrip species and mite species, particularly those that are pests of floriculture. Biological control is not only restricted to the release of living organisms, some techniques such as sprinkling, which is very common in floriculture, are not only useful for the application of synthetic chemical active ingredients or foliar-type fertilizers, they can also be applied, for example, entomopathogenic fungi or bacterial solutions such as Bacillus thuringiensis, for example, that can come in formulations that are compatible with sprays as liquid mixtures with water. The productive process of the carnation, from the initial week of planting to the moment of the first peak, is approximately 26 weeks on average. Some more varieties according to their phenological development and according to each variety, they can last more or less than the average. They are about 26 weeks old at the first peak. After the first peak passes, the second peak comes, which is what we call peeling. Approximately its maximum week of production of this peeling occurs at 52 weeks of age of the crop. Passing this peel comes a time of establishment, which we call them, where the plants are taken until in the case of our farm they are 80 weeks old. Climate variability is a global phenomenon that affects flower production and agricultural production in general. Particularly in climatic variability we have that there are effects on organisms that are considered pests. However, there is also an interaction between what happens in our flower crop of interest in this case and what can happen with biotic and abiotic factors. The situation of being able to have very sunny days with high radiation or very rainy days, they can affect in a transversal way everything that happens in production parameters and of course in the behavior and dynamics of pest cycles. Then Senaflores also works on factors of innovation related to the understanding of data in the geospatial interpretation and spacetime dynamics of these data related to climate variability that is a global phenomenon. The cutting and classification, which are the fundamental tasks in the carnation production process, require approximately 75% of our daily time. The cutting task consists of locating the stem that gives us the opening required by the post-harvest and by our client. Once the stem is located, the cutting work is carried out, guaranteeing a clean cut. This clean cut consists in that at the level of the cut, which must be leaving 5 pairs of leaves, from the base of the plant upwards, we must guarantee that at least 5 pairs of leaves remain. This to guarantee a future peak or peel that we call. This clean cut consists of that 5th pair of leaves remaining in the best way without doing any damage, so that diseases do not enter, nor do we lose photosynthetic capacity of the plant. Just as we should not leave long stumps, make the cut very high. These stumps can cause rot and generate hormones that limit the growth and development of the peel that comes to the future. Also in the clean cut, which is a very important task, we must guarantee the disinfection of the tool or scissors, which must be introduced into the bed to locate the stem, in a closed manner until the stem is located and no make cuts on stems that are not for the point of the day or false cuts. What would it be called? This scissors or cutting tool is disinfected with a product, which guarantees us the disinfection. The stem has already been cut. It is removed from the bed and taken to the classification table, where, according to the orders that have been given previously to the crop, the classification is made, according to the degrees of the flower that can be select, fancy, standard, or in the national case, which would not work for export. My name is Blanca Alarcón. I am currently a vegetative supervisor at the company. We are going to start the classification process. We start by classifying the highest ones, which are the select grades. We also separate openings. There are different openings. Here we see more or less 4 openings in the tub. We are going to start classifying the most closed ones. Point 1. The number of flowers per bouquet, 25 flowers. 15 go up, 10 in the bottom crown, and now we make the second crown that go 10 around. More or less leave them about 2 centimeters, so that the light can be seen from one side to the other, so that there are no crowns glued. This point of cut or opening point is handled for Japan. It is ready, we are going to cut it. We are going to use. Here we handle the 3 colors of rubbers. Yellow, which is the select grade. Blue, which is the fancy grade, are shorter. The standard, which is shorter, and the short grade, which is green. We place the rubber on top, and we are going to cut. We measure it. On the table there is the measure to cut. We place it like this so as not to cut the little fingers. After having peeled the legs, more or less a fist and a half, we strip it. Now we are going to put the yellow rubber on the leg. We give it 3 turns, so that the leg does not come loose. We leave it as if it were one by itself. We cannot leave it uneven. We leave it as if it were one by itself, which is a fist away. We verify that there are no buttons left, and we remove a little turn here because they will be boats with a turn here. We put a code from the classifier on this one. We put it on the neck of the flower and we have a finished product. We put it inside the basket. Usually 3 opening points are handled. Point 1 that is handled for customers from Japan. Point 2 also goes to customers from Japan, and point 3, which is this, goes for customers from Russia and the United States. Genetic improvement in floriculture is a very important innovation parameter. Particularly in species such as the carnation, for example, being able to generate new ones and develop new varieties that have tolerance or resistance to pathogenic agents such as fusarium, is beginning to gain importance. There must be a balance not only in phytosanitary aspects, but also in aspects of quality and market demands. For example, I can have varieties that have tolerance or resistance to pathogens, but also that meet parameters such as color, durability, and that can withstand long trips, because the trend has also been not only export by air but by sea. If some markets require variety in colors, variety in shapes, these varieties also have to be adapted to the climatic conditions of the region where they are planted. In addition, to be able to tolerate the conditions typical of what has to do with pests that will affect their entire production cycle before they can be cut and exported. The cultivation of the carnation year after year has been gaining more importance and has been growing, gradually gaining strength in the Japanese markets, as well as in the European community, and the same in the United States. Our key at this time is the second largest export product, after the rose. but at the world level Colombia is the first exporter of carnations. Many types of data are captured in floriculture. There is data that is captured from phytosanitary aspects, from production and in general from the entire operation of the floriculture sector. Having all this accumulated data also requires that there be innovation challenges related to data intelligence and machine learning. It is being able to work with all the interpretation of the data, draw curves in real time and make mathematical models, which allow generating models predictive, not only for flower crops, but also for aspects of the behaviors and dynamic temporal spaces of pests. Being able to capture data is when a monitor approaches the production system and can make a numerical count of the number of stems, for example, per square meter, or the number of captured individuals or incidence in severity graphs, which are phytosanitary parameters. Numerical that they may have on their spreadsheets and that can then be taken to statistical programs to be able to interpret these data in graphic figures and real-time sequences that allow us to understand how our crop is doing both in terms of production and phytosanitary. When you have all this amount of data, ordering the data and understanding it statistically is a key factor in decision-making. Being able to make decisions is key in agricultural systems, and floriculture is no stranger to decision-making. It is better to anticipate decisions in aspects of phytosanitary and production and not when we are already at key moments of production. That is why taking data and interpreting it is a key factor that allows the chain to make decisions at specific points of production. Having decision parameters, for example, in irrigation factors and key decisions, where programs and software allow to automate irrigation or generate spraying factors or program certain crop management conditions, would allow Colombia and our flower sector to start to grow in the areas of automation. To have a lot of data and to have this data in intelligent software that does the work for us through data intelligence. The use of sensors and the interpretation of that data for decision-making makes that in real time our technicians and agronomists make decisions in real time. This can also be scaled even to the fact that the sensors send signals to specialized software that allow the generation of automatic irrigation, programmed irrigation, and why not in the future phytosanitary sensors that allow in real time to map the space-time reality of pests and diseases in the flower sector. Our process after the cut. The ladies, after placing the bouquets already assembled in the baskets, the carters transport them to the post-harvest area. In the post-harvest area, they unload it in our hydration area, which contains STS and in which we give 2 hours of hydration to our flower, in order to guarantee 15 days of vase to our clients. After the 2 hours of hydration have passed, we have some people who choose the varieties of baskets by variety and come to our area of storage or to the dispatch area. In our area there is a person who keeps our flower, carnation, mini carnation or green ball, for 300 stems. This after they are packed, a label is generated with the date of entry, in which the flower entered the variety in the number of branches and stems, enter our storage area, so that the sales people can see what we have available for sale. The flower that passes straight to the office. The packing girls know what the customer goes for due to a label that is generated. For them, with that label they know what cap it goes in, how many stems, number of bouquets, and what the customer is destined for, that is box, tobacco, quarter, eighth, and then our zanchado area passes. the Zanchado guys must also know what lid it goes with and what clients it is for. Our office boys bundle, assemble cars for 8 full boxes and go to a pre-cold area. In the pre-cold area the flour lasts an hour, in order to lower the temperature and guarantee our temperature, which is at least 3 degrees, and that's at this stowage per client, according to the client, is labeled for dispatch. Our trucks must also arrive at a minimum temperature of 3 degrees. Loading and dispatch begins, and they must guarantee a minimum temperature of 3 degrees from here to the airport. Previously I commented on the growing demand for flowers in the world, to more than 100 countries. This has meant that we not only export our flower by air but also by sea. Many species of flowers do not meet some parameters to be exported by sea, given its durability conditions. The carnation in particular is a species that adapts very well to being exported by sea. In addition to being one of the species that has the longest life in a vase, when a flower is sent to another part from the continent such as Asia, for example, they can be trips of at least 20 to 30 days depending also on what can happen in the logistics chain. And then the promise of value is that these flowers, after they are landed in a country like Japan, can have a life in a vase from 10 to 15 to 20 days. The cultivation of the carnation is a very demanding crop of labor, is very dynamic in the tasks that have to be done. It goes, too much time is spent in vain now, that's why. It requires a lot of operational personnel. Most of our collaborators are women. I think that it could be between 80 and 90% are women heads of family because they support their household. COVID-19 was definitely a disease that affected economic interactions around the world. Not only in the agribusiness sector but in general in all economic sectors, there was a break on exports due to the restrictions that some countries impose or imposed on its moment in 2020 to 2021 for mobility, the containment of the COVID-19 disease. Floriculture was not immune to the situation of the pandemic, but despite this and thanks to the programs led by Isocleflores and Semiflores, it was possible to continue exporting, something very key, and that is that the consumption of flowers began to grow in the world thanks to the fact that many people being at home saw an innovative and inspiring experience to be able to have flowers that with their colors and aromas could be in their home adding value. This allowed them to come from Colombia, from the flowers of cultivation, to the homes of the more than 100 countries where we export. The flowers began to reach these key spaces, because as many people were at home through teleworking, through the new schemes and the new reality, post-COVID-19, flowers began to complement the new spaces and the new reality to which we are adjusting very well.